So now we're going to be looking at torques and how this links into equilibrium of a rigid body. So the torque and moment of a force are often conflated into either moments or torque, but there is a distinction to be made. Torque is actually just a moment with no resultant force. So for instance, if you're operating a vehicle and you decide to turn, your arms are actually going in the same direction, but there's actually no resultant force acting on it. So even think of it like, that's a bit of a bad example, but if you're turning on a tap, for instance, so you have these little bits and you turn a tap, there is essentially no resultant force acting on it as the tap turns. So these essentially go in opposite directions, but there is a net turning force. So as vectors in instantaneous moments, they look like this. So there'd be no resultant force, but there will be a resultant torque. So essentially a torque calculation is the same as a moment calculation, except for the fact it's only if there is no resultant force on the object. And if there's no resultant force in the object, but it is turning, essentially. For rigid bodies, however, if we want them to be in what's known as total equilibrium, this is what we have to do. So if it's in total equilibrium, then the first thing that has to be true is the magnitude of the forces acting in one direction is the same as the magnitude of the forces acting in the other direction. So essentially, this is similar to forces up equals forces down from circular motion, but just represented in terms of rigid bodies. The second thing that has to be true is that the net sum of the clockwise moments and anti-clockwise moments about any point is 0. So essentially, if you pick a point on a ruler that has some forces, not only do the forces have to be equal, but the net turning force or net moment has to be the same both clockwise and anti-clockwise. And we're going to go through 2 examples of that in the next 2 videos.